In 1772, on a landed estate in Cheshire, England, a clockmaker finished building something that should not have worked. John Whitehurst had been hired to solve a simple problem. Water needed to reach the brew house and the estate offices, but the source was too low. No horse, no windmill, no steam engine available. Whitehurst built a machine instead, a rigid pipe, 2 valves, an air chamber, and watched water climb uphill on its own. 3 years later, he wrote to the Royal Society. The water rose, he explained, by its own momentum. The most rigorous scientific body in the English-speaking world published his findings without objection. The machine kept working. It crossed the Atlantic within 2 decades. By 1798, the Portsmouth Aqueduct in New Hampshire was calling it the perpetual pump. 250 years later, the device is still deployed. In the Philippines alone, more than 595 systems serve nearly 300,000 people daily. Researchers at Delft propose using it for energy recovery in modern water distribution. And yet, no American building code has ever created a pathway for it. No standard engineering specification lists it. The global pumps market runs on motors and electricity, and this machine asks for neither. It is called a hydraulic ram pump. This is not a story about a machine that failed. This is a story about a machine that was standardized into invisibility. Welcome to Forbidden Manual. The archive opens in 1775 in the pages of the Royal Society's Philosophical Transactions, the same journal that published Newton, Hooke, and Franklin. The paper is written by a clockmaker named John Whitehurst, and it describes something that should not work. 3 years earlier, on the estate of Philip Egerton at Alton in Cheshire, Whitehurst had built a machine. It raised water from a lower source to a higher destination, to the brew house and the estate offices, without a horse, without a windmill, without a steam engine. Whitehurst's explanation was precise. The water rose, he wrote, by its own momentum, not by external force, by momentum already present in the falling stream. The machine worked, it kept working, and in 1775, Whitehurst presented his findings to the most rigorous scientific body in the English-speaking world. This was not folklore. This was peer-reviewed physics 250 years ago. But Whitehurst's design had a limitation. It required someone to time the valve by hand. The machine could lift water, but it could not run itself. That changed in 1796. They coded it out. They can't code out physics. Subscribe. The next archive opens soon. Now let's get back to the investigation. In the town of Voiron in southeastern France, a paper mill owner faced a familiar problem. Water needed to reach a height the stream could not. The mill owner's name was Joseph Michel Montgolfier. You may know him for something else. 13 years earlier, he and his brother had launched the first successful hot air balloon. Now, Montgolfier turned his attention downward to falling water and the energy it carried. He invented the self-acting hydraulic ram. The machine ran itself. No hand on the valve, no timing required. Water fell, pressure built, a valve slammed shut, and a smaller stream shot upward. The cycle repeated, 30 times a minute, 60, 100. The stream became the engine. No wire, no motor, no bill. Word traveled fast. By December of 1797, Matthew Boulton, one of the most powerful industrialists in Britain, partner to James Watt, builder of steam engines, had filed British patent 2207 on Montgolfier's behalf for an apparatus for raising water and other fluids. Consider the irony. One of the fathers of industrial machinery helped formalize a device whose greatest selling point was that it required no industrial inputs at all. And then the machine crossed the Atlantic. In 1798, the Portsmouth Aqueduct in New Hampshire installed a hydraulic ram. The local description was not modest. They called it the perpetual pump, capable of lifting a barrel of water every minute. Perpetual. That was the word they chose, not perpetual motion. Engineers in 1798 knew better than to claim that. Perpetual operation, a machine that ran without rest, without fuel, without human labor, as long as the stream kept flowing. The valve slams shut. Pressure explodes, water climbs. By the end of the 18th century, the hydraulic ram had earned a British patent, a Royal Society publication, and an American installation that called it perpetual without embarrassment. The physics was proven, the elegance was undeniable, more than 2 centuries old, still working today. What happened next was not a failure of engineering. In 1975, an engineer named H.W. Everson published a paper in the Journal of Fluids Engineering, the flagship publication of the American Society of Mechanical Engineers. The paper was titled An Analysis of the Hydraulic Ram. By then, the device was nearly 200 years old, and engineers were still writing peer-reviewed analyses of how to optimize it. Iverson was not alone. In 2018, Chin Han Chuan at University Sains Malaysia ran experiments varying supply head, delivery head, and air vessel geometry. The same year, Nikita Mishra and colleagues published data showing that impulse valve beat frequency, the rhythm of the machine, could shift efficiency dramatically. Increasing beat frequency from 65 to 76 cycles per minute changed everything. More water wasted, less water delivered. The machine looks crude. It is exquisitely sensitive. So how does it work? Think of a freight train. A loaded freight train moving at speed carries enormous momentum. The faster it moves, the harder it is to stop. And if you stop it suddenly, if you throw a barrier across the tracks, the energy does not vanish. It transfers. It crashes. A hydraulic ram harnesses that crash. Here is what happens in real time. A rigid pipe, the drive pipe, fills with moving water from a stream or spring. The water accelerates downhill. At the bottom, an impulse valve sits open, letting water spill freely. The flow builds speed. The instant the flow reaches a critical velocity, the valve slams shut. The moving column has nowhere to go. Water is nearly incompressible. The momentum of that column converts instantly into a pressure spike, a shock wave called water hammer. The same phenomenon that makes pipes bang in old buildings. The same physics that can rupture poorly designed plumbing. But in the ram pump, that shock wave has a destination. The pressure spike forces open a second valve, the delivery check valve, and pushes a small volume of water into an air chamber. The air compresses, absorbs the shock, and then pushes that water up the delivery pipe, uphill, higher than it fell. The impulse valve falls open again. The cycle restarts, 30 to 100 times per minute. No switch, no motor, no external input. 2 moving parts, that is all. The numbers seem impossible. Practical Action, a British engineering charity with decades of field experience, reports that under favorable conditions, more than 50% of the energy in the driving flow can be transferred to the delivery flow. Not 50% of the water. Most of the water spills out the waste valve. 50% of the energy. The machine sacrifices volume to gain height. A larger flow falling through a small drop lifts a smaller flow through a much larger rise. The physics is not magic, it is leverage. It is momentum, redirected. The stream is the engine, the crash is the mechanism, the air chamber is the cushion, and the delivery pipe carries water uphill, without electricity, without fuel, without a monthly invoice, as long as the source keeps flowing. A pump that needs no power, a system that creates no bill, engineering that asks for nothing except falling water and patience. That was its triumph, and that was its problem. When electricity reached the American farm, everything changed. The Smithsonian documents rural electrification as one of the most transformative shifts in agricultural history. Electric power brought light to farmhouses that had known only kerosene. It brought refrigeration to dairies that had relied on ice cellars. And it brought a new kind of pump, motorized, controllable, instant. The electric pump had a plug. It had a breaker, it had a bill. It fit into a system that could be metered, serviced, and sold. The hydraulic ram had none of these. It asked for nothing. It generated no recurring revenue. It required no technician, no replacement parts, no annual inspection. Once installed, it simply ran on physics that predated the grid and would outlast it. That made it invisible to the infrastructure being built. Today, according to industry estimates from Mordor Intelligence, electric motor-driven pumps account for approximately 75% of the global pumps market. The hydraulic ram does not appear in procurement catalogs. It does not appear on standard bid sheets. It does not appear in the engineering specifications that contractors pull from software libraries. It is not banned, it is simply not listed. But the absence goes deeper than catalogs. If you find a spring on your property, a spring that flows year-round, that drops 12 feet to your garden, you might read about the hydraulic ram. 2 moving parts, no electricity, runs indefinitely. You might think, this is the answer. Then you call the county. The first question, do you have a water right? California's State Water Board is explicit. You should not assume that an existing diversion pipe or facility gives you a legal right to divert. Post-1914 appropriative diversions generally require permitting and licensing. The second question, does your diversion require a hydraulic project permit? Washington's Code WAC 220-660-010 states that anyone who wants to use, divert, obstruct, or change the natural flow or bed of fresh or salt waters generally needs a hydraulic project approval. The third question, are you connecting this to potable plumbing? Washington's Plumbing Code WAC 51-56-0600 requires backflow protection for potable supplies serving irrigation systems. Annual testing, approved assemblies. The fourth question, who is your licensed installer? The spring has not changed, the physics has not changed, only the paperwork has. They electrified the farm and made the motor pump the default answer. They wrote rules for cross connections, potable protection, and permitted diversions, rules that assume equipment with serial numbers and power inputs. They subsidized electric infrastructure and made the motor pump easy to finance, easy to permit, easy to specify on a bid sheet. They built a procurement system that cannot see a machine with no manufacturer's warranty and no wiring diagram. They created licensing structures with no category for a device that has two moving parts and no electricity. They did not need to ban the hydraulic ram. They only needed to make the conventional path easier. No regulator sits in an office scheming to suppress the ram pump. The conspiracy theory is the wrong frame. The truth is structural. The codes, the permits, the appraisal categories, the bid specifications, they were all designed around equipment that plugs in, equipment that can be inspected, equipment that fits a category. The hydraulic ram fits no category. And what fits no category finds no pathway. You cannot meter the stream. You cannot sell the shockwave. You cannot build a subscription around physics that asks for nothing. The machine solved the wrong business problem. It works where there is flowing water, a drop, and patience. It does not create dependency. It does not generate demand. That is not conspiracy. That is economics. And economics writes the codes, but the machine never disappeared. It simply moved to places where the grid could not follow. In the Philippines, an organization called AIDFI, the AID Foundation Incorporated, describes the hydraulic ram as a forgotten technology, that it recovered and improved starting in the 1980s. AIDFI's technicians travel to mountain villages where no power line has ever reached. They install steel-bodied ram pumps fed by streams and springs. The machines start beating, water climbs. The numbers are not small. AIDFI's current program reports more than 595 systems installed, more than 295,000 people served daily. Technology transferred to Afghanistan, Nepal, Colombia, Mexico. Lifts as high as 240 meters achieved. No wire has ever been run to these sites. None is needed. The ram returns, not as museum piece, but as infrastructure. In Moralibanjang, a village in the Nepali hills, a hydraulic ram pump was installed in 2011 by Renewable World, an international development organization. The documented results, 86,000 liters per day pumped 45 meters uphill, 14 households served. Downstream improvements in irrigation and nutrition measured and recorded. The machine has no plug, it has no bill, it has no expiration date, 14 families, one pump. Beating since 2011, and the technology is not standing still. In 2022, researchers at IHE Delft Institute for Water Education, Maria Salinas Rodriguez, Kennedy, and David Ferris, published a paper proposing something unexpected. They argued that hydraulic ram logic could be used for energy recovery inside modern water distribution systems. Excess pressure that is currently wasted across pressure-reducing valves could instead pump water to elevated storage. The ram pump returns not as nostalgia, it returns as engineering. For the homesteader, the numbers are within reach. Clemson University's land-grant press publishes an extension guide for homemade PVC ram pumps. Estimated cost for a simple build, $150 to $200, depending on location and pump size. Build It Solar documents a 1 1/4 inch fitting setup for approximately $120, $150 in PVC fittings, a rigid drive pipe, an air chamber, 2 valves, That is the bill of materials for a pump that runs without electricity, without fuel, without a monthly invoice. The machine is not free, but it is close, and it never asks again. This is the pattern. Earth tubes were sidelined by moisture concerns, and indoor air quality codes. Site-specific systems lost to standardized HVAC packages. Passive solar direct gain design works beautifully when done well, but appraisal structures and production building norms favor mechanical conditioning. Rainwater harvesting is technically straightforward, but the moment the tank touches modern plumbing, cross-connection codes, treatment requirements, and backflow rules multiply the paperwork. Gravity-fed spring systems still serve remote communities around the world, but potable water regulations complicate any attempt to adopt them inside code jurisdictions. The pattern repeats. Building methods that eliminate bills are systematically harder to permit, harder to finance, harder to specify. Not banned, just absent, not illegal, just uncategorized. The system does not need to conspire, it only needs to make the conventional path easier. They will not tell you that a machine with 2 moving parts has been pumping water uphill since 1772. They will not tell you that nearly 300,000 people in the Philippines drink from hydraulic ram systems every single day. They will not tell you that researchers at Delft are now proposing ram pump logic for modern municipal water systems, not as a relic, but as a recovery tool. They will not tell you that the stream on your property has been holding kinetic energy since before your house was built. 250 years ago, John Whitehurst wrote to the Royal Society about a machine that raised water by its own momentum. The machine still works, the physics has not changed. The momentum is still there, in every stream, every spring, every drop of falling water that moves downhill, and could be asked to lift something up. The hydraulic ram does not advertise. It does not require subscription. It does not send a monthly statement. It does not need a firmware update or a service contract or a licensed technician. It simply waits in the physics of moving water, in the patience of a valve, in the compression of air inside a chamber, in the shock wave that repeats 30 times a minute, 60 times, 100, as long as the stream keeps flowing. The stream is the engine. The crash is the mechanism. The silence between beats is the only maintenance it asks. A pump that runs without power, a system that asks for nothing, engineering that predates the grid and will outlast it. If this video helped you see what was hidden in plain sight, share it. Every share builds what standardization tried to bury. Every view recovers what the catalogs forgot to list. The archive is not closed. Next time on Forbidden Manual, a cooling system that runs on water and gravity alone. No compressor, no refrigerant, no electricity. The physics has been documented for over a century. The code has never mentioned it. The archive opens in 1904 on the rooftop of a Chicago meatpacking plant, where engineers discovered that the night sky itself could be a refrigerator. Subscribe now. The next suppression is already being